So, hi everybody. Hopefully you can see the poll as you're coming in. This is a pretty exciting session for us because of a whole bunch of reasons. One, we learned about Chris and the amazing work from the measurement lab just about 3 weeks ago. And when we learned about the great data set that we had, we also learned that he is in Baltimore. So we asked him if he would join us for Baltimore Data Week since we were kindred spirits. And luckily we were able to kind of grab his time exactly on the day of the theme that's around digital equity. So we've had lots of questions about who has access to devices and that kind of thing. But one of the things that we've learned during COVID-19 is that we don't know how fast people's access is. It's not just enough to have the device. You actually have to have a device and the internet coming into your home that's fast enough for you to be able to either work or learn or do all those other things that we do possibly in school or at our job. And it's been a real hindrance for some of us. The other thing that I wanted to note to you, Chris, we have this poll about people's SQL and data querying abilities so that you know who people are. But we also really suggested, because this is a national data set, even though you're going to talk about Baltimore, we are part of the National Neighborhood Indicators Partnership. And so we invited some of our other partner cities to join us too. So if you are from one of our partner cities, you might want to put that in your name so that Chris knows where he or who he's talking with. So this is an intercity conversation, hopefully, as well as obviously focusing in on the neighborhoods here in Baltimore. And then tomorrow, we are going to have one of our data science interns who worked with Chris over the last couple of weeks talk about some of the things that she learned by accessing the data. So I am going to turn it over to you, Chris, and hope you have a great session. Thanks everybody for joining us.
Thank you so much, Seema, and really appreciate the opportunity to be with you all today. Just need to share my slides here. Give me just a second and we'll get through this. So it's really a pleasure to be here, and it's my honor to receive that invitation. I'm so glad that it worked out. Digital inclusion, digital equity are spaces that I have volunteered in and worked in as well. And it's a part of a core reason why I came out to the East Coast about 7 years ago to work on projects like MLab. And so my goal today is to give a broad overview of both the MLab project, our data sets, so that you can understand just at a high level who we are, what we do, why we do it, and then also to give some examples for those who might want to get started looking at our data, and a couple of everything from basic to more advanced ways to do that. I believe the slides are linked in the website agenda, and so my goal is to plow through as much of these slides, get through this information so that you can go back to it, review it. There are some links in the section around querying too, so if you're looking to get started and get your feet wet on our data, there are some kind of self-guided tutorial resources that I've linked to in some of the later slides. So with that, thank you for joining us today. What I want to talk about with you today is Measurement Lab, MLab's open data sets and platform for internet performance measurement, and it's kind of an introduction. So let's jump right in. So what I want to cover is on this list. What are we? How do we measure the internet? What do people think our data is valuable for? And part of that is why we think it's usable and valuable. How can you use it? How do we support communities who want to use our data? And then specifically about Baltimore, just probing some questions about how might we measure the impact or inform Baltimore's digital inclusion initiatives. And yes, if you have questions, ask them in the chat. We're going to try to get through as much information as we can, and then queue up and have a conversation at the end. And if you are interested in jumping ahead, I see not too many people have marked intermediate or beginner, but if you want to get started right away while I'm talking about all this other stuff, there's some links here in the slides to get started. You just need to sign up a Google account to our Google group, and that gives you free query access. And then the rest of these links are for getting started or requesting help. And if you email that email address, you're going to get a reply from me. So later on, when you come back to all this and you're like, I want to get started on this, just email support@measurementlab.net. So what is MLab? This is our mission statement, which is really like aspirational. We want to measure the internet, save the data, and make it universally accessible and useful. And there are lots of different ways to measure the internet. And if you've looked at the different testing, the different speed measurement tests out there, and government initiatives and corporate initiatives, there's so many different ways. Everybody wants their own test, and MLab is providing one way to do that, and these other pieces. So let's rewind about 10 years. We started this project back over 10 years ago, when there was a need for a solution for this lack of infrastructure that was maintained with great connectivity to support measurement of internet connections. So researchers had approached Google at that time to can you share your data, your analytics, your private proprietary data? And of course they said they couldn't do that, but that was when Google was young enough to really still be exploring a lot of things that they may not be exploring now. And MLab was started as an initiative in a partnership with Google. The other thing that didn't exist that long ago were the ability to share large data sets with one another and with other experts easily. And so we're at this cross section of public engagement and interest in a subject that affects us all. How well are we connected to do the things that we need to do? And also the academic side, the research, but there's a large policy overlap as well. And so fast forward now, MLab is a platform that we use to allow people to submit tests of various types, to a pipeline to collect that data, and tools to make it available. Data making it available in various forms, tools to collect additional data, and tools to support community initiatives to gather additional data. And of course, we're a team as well. So really briefly on that. MLab is a fiscally sponsored project of Code for Science and Society. Codeforscience.org will give you more information about the other programs that are housed at Code for Science, and we're really pleased to have been there since last March. We're working towards scaling toward our own nonprofit status, and so that's why we're under a fiscally sponsored program. Code for Science is great, and they support open science, open data initiatives, and you may be familiar with some of the tools that some of the other projects that they provide. Our program director is Lad Yi Olsen, and I'm our program management and community lead, which is long form of saying I do some research with our data and some communities, but I also lead our community engagement and support on the platform. And then we have a couple of platform engineers, Nathan and Roberto, who manage a lot of the day-to-day work with our partners at other contributing organizations. And over the years, those have come from a variety of organizations listed here. Google, as I mentioned, is a core contributor, and so they support the Measurement Lab project by contributing research, infrastructure support, and they assign a small team of engineers at Google to write open source code for the MLab platform and pipeline. How do we measure the internet? And so these details I think are important to understand the provenance of what we do and the instruments that we use to do it, and to illustrate the transparency that we have, and which is our focus. We run an off-net platform, and that I'll get into in a moment, but that consists of about 60 metro areas around the world right now, with about 500 plus servers. In each location, there is one or more server pods. A pod is redundant hardware, 4 servers and 1 switch, which we can use to host measurement services. Off-net servers, what does that mean? Off-net hosting means that we're placing our servers intentionally in data centers where ISPs peer with one another. In other words, outside of the access networks that we all subscribe to in our homes and businesses. And that's because we want to measure what we would consider a full path from the end user to content that could be anywhere on the internet. As you know, or may know, the internet itself is a network of networks interconnected between one another using standard protocols. And off-net means we're measuring that inter part of the internet. It's one way to frame that. On our servers, we host measurement services. These are the tests, right? For want of a better term, proposed by tool builders who are actually sometimes academic computer scientists, network engineers. They're wanting to study specific aspects of the internet and provide a globally distributed way to do that. New tests are submitted to us and reviewed by our review committee. And once approved, our engineering team works with those tool developers to launch those clients, so those tests. That server code lives on the server, and every test that every test or measurement service that we provide has a server-side component and a test client component. So the client, we require all of these to be open source code, and for tool developers to develop an open source reference client, we call them, so that anyone can take that code and use it, right? And so these are good examples of two integrations of our tests. Google search team about 2-3 years ago, 4 years ago maybe now, integrated into their search feature. This is probably, if you've learned about MLab at all, it may have been doing a Google search for an internet speed test or how fast is my internet, and they provide a little widget to do that. There are others, of course. Here on the right, we're displaying the UNI application, which stands for the Open Observatory for Network Interference. This is a project within the TOR project. And so they provide, they're doing research on internet shutdowns and blocking and throttling, primarily in international locations. And they integrate the NDT speed test and the Dash streaming test. And I'll explain in a little more detail what those are. But this is the real value of, one of the real values of our platform. It is open enough that you could put our test in your web page, or you could add it to your software that runs on your computer at home, or you could add it to a product that you produce. If anyone is familiar with the FING project, they are a corporate, a commercial company that integrates our test into a network appliance that you place inside your network to get statistics about security and that sort of thing. So what is our data? MLab data could be referring to a lot of different things, from the data generated by any one of our measurement services, or it could be one of the specific tests, data from that test. NDT, or the Network Diagnostic Tool, is our largest used test, and when people refer to MLab data, often they're referring to the NDT speed test data. So what does NDT measure? And this is important to note, NDT measured something called bulk transport capacity. And if you view the NDT page on our website, there's some links to give more context to what that is. But essentially, it's the rate at which the TCP protocol can deliver data over your connection. In other words, the reliability of your link, of your connection, is what we're measuring. And NDT does that with a single TCP stream, because we're seeking to measure a baseline for that connection. So what we're not measuring is the maximum bit rate of the link. So often when folks are running our tests, or they're emailing us to say, I measured using your test and I measured using these other 3 tests, and because the measurement values, the names of the metrics are the same, like upload speed and download speed, we might assume that they are measuring the same thing and they should be equivalent, but that isn't the case. And I'll explain that in a bit more detail next. So single stream. Single stream is, as I said, an effective baseline for measuring the performance of TCP on your connection. And multi-stream tests exist as well, but typically multi-stream tests are seeking to measure as close to the total link capacity as they can. And that is the real difference of those two tests. In situations where we've run, let's say, speedtest.net and the NDT test side by side from the same computer and the same connection over time, the trend in measurements typically on a well-connected library, for example, are roughly equivalent. So it's not that one can't measure the other and one is valid and the other isn't. We typically recommend that both of these are valid ways to understand different nuances of a connection. And it's confusing because all of our modern web browsers open up multiple streams of data, multiple TCP streams, and they specifically do that to compensate for a data packet loss problem, which is a problem within the TCP protocol as well, in the way that data is exchanged. So for years, modern web browsers have been adding support for the multi-stream test. And so when you're measuring, let's say with Ookla, you're trying to measure the total link capacity. And when you're using NDT, you're measuring the reliability, a baseline measurement of a single stream's performance. So the two are actually complementary. And there's some other nuances here that make those two platforms specifically different, which I'll touch on next. So, well, just in summary, why is my MLab test result different than X? And these is just a quick summary of those most common reasons. The off-net placement of servers versus on-net placement of servers in some other platforms, bulk transport capacity versus link capacity, and single stream versus multi-stream. If you'd like to dig in deeper and learn a bit more about this and our perspective on it, the link here is to a blog post that we wrote a little while back that really addresses these nuances in a bit more detail. So touching briefly on MLab's other measurement services, Dash, which I mentioned a moment ago, excuse me, stands for Dynamic Adaptive Streaming over HTTP. And if you remember the way that you used to use audio players like Winamp, or, this is back in the day, but there's a specification that's open at the IETF for video streaming. And Dash emulates that video streaming standard in order to measure the video streaming quality of a connection. And then another test that's recently launched on the platform is called WeHe, and it's measuring the differential treatment of applications by ISPs. And it was developed by Dave Chaffney's team at Northeastern University. And I've neglected to mention the UNI team developed the Dash test. More information on all of our tests is there. One thing I will mention about WeHe is that it is a mobile application test. And so there's a mobile app, and one of the interesting points about WeHe is that it's currently in use by ARCEP, which is the FCC of France, and they are using that in order to effectively measure net neutrality. The other thing that we do, and this goes to the deep transparency that we try to produce at MLab, we use what we call Sidecar services to gather even more rich data and to contextualize and inform deep research for those researchers who want to go deep into the internals of TCP. For every connection made to a MLab server, your IP address is collected, and our traceroute core service collects a network path information from our server back to that client, and that data is saved both in raw format and in BigQuery. And then, of course, the packet header service is capturing information about, this is the piece that's capturing information about the session that between you and our server when you run a test. And that data is also available in its raw format. Typically that's used by more advanced researchers. And then finally, the last Sidecar service is called TCP Info. And this is really the statistics engine in the Linux kernel that, in the Linux operating system, excuse me, that reports statistics about every connection that's coming in over TCP. And we use those to gather very low level metrics about each test. So what makes the data valuable to people? And this is coming from a lot of different areas, but one of the things we think is valuable for is to illustrate the value of aggregate data. And by design, NDT data is an aggregation of many connection results. And so looking at specific geographies like Priya is doing in Baltimore, like I did a little bit as well, or other communities that want to see, okay, so for these geographies, how are we faring on according to the NDT test? A single test is okay, but typically we like to say test regularly and test at normal times, and when you can, do scheduled tests. And that way you have a trend in performance for a location that you know about, your home, your business, your anchor institution, etc. And that's really more valuable than a single point in time measurement. And we share that with people because it's really important to sort of think about how a measurement at one point in time, it gives you the value you had right there, but conditions on the internet change quite rapidly, and it's important then to look at the trend line. This, on a larger scale, helps us look into trends globally at internet performance, so we can see patterns that help us to ask better questions. And we'll get into some of those questions on a local level here in a little bit. One other piece about the value is the scale and longitudinal value. So we've been running NDT for over 10 years. We have, I think this is out of date, 3 million new measurements worldwide per day, over 2 billion test rows. That's upload tests and download tests combined, upload plus download. So it's huge. So, our default data is huge and can help inform a lot of general trends in specific regions, specific areas. There is a limit to that geography, which I'll get to in a little bit. But lastly, I think we are open, free, and public. All of our code is open source. All of the client code is open source. You could reinstantiate the entire MLab platform, given the development staff to do that, just by looking at our public GitHub archives. We publicly archive all of the data, all of the raw data, and we put it all into BigQuery so that it's more accessible. And then what's not on this slide is that we license our data in the public domain. And this is really key. Like, no one else is doing that. So it's a huge value. And the potential value really is of this data is really what keeps me going, because it helps inform folks like you and what you need to know to make decisions or understand the efficacy of what you're up to. All of our tests are active, meaning that people opt into them. You have to actively say, I want to do this. There are some measurement platforms that are passive, where you're not aware that something is being collected. That's not part of what we do. And it's just interesting to know that a lot of our tests come from outside the U.S. as well. So it's a global platform. As being based in the U.S., obviously we often have more contact with folks in the U.S., but that's changing as well. And then lastly, privacy. We're very concerned about user privacy, and this is both an important thing to note because we care about it, but also there's some things about this about our choice in privacy, that in protecting user privacy, that limit the default data's efficacy or usability at very granular geographies. So we collect IP address. Is somebody unmuted? Sorry, call that out. We only collect the IP address assigned by your ISP, and we also make available means for you to strike or remove your test results using our privacy policy. And many of you might be aware of California's data privacy law and the European Union's general GDPR, General Data Protection regulation. Both of these protect people's privacy and the data that we collect about them. So if we do have clear guidelines for that in the privacy policy, and we're probably the most privacy respecting platform that does this. Accessing the data, and this is the piece that you came here for in all likelihood. There are lots of different ways to do that. We have a wide range of audience, different types of audiences from different knowledge backgrounds, training, expertise. And so we try to present a range of options to allow that to happen. Now, our visualization website is currently in the process of being upgraded. So if you try to click on this link, it's going to go nowhere. Go to our main website and click on visualizations, and I'll touch on what we've got right now. The main, the question in the poll about SQL or SQL query languages was drawn from this piece. The main and most flexible place for people to research and use our data, is using BigQuery. BigQuery is a large distributed database platform from Google, and it uses standard SQL or structured query language to provide that access. And we load all of our data into BigQuery, and the sign up for our discussion group on Google Groups that was on my first slide is how we provide free query access. It's the most flexible option, but it also is the highest learning curve if you don't have folks on your team who are used to working with data, used to working with databases. So it can be a high onboarding curve, but it's very flexible. And if you're using tools like Tableau, RStudio, or programming languages, there's lots of different ways to interact with that data. I could go on and have a whole nother slide deck on integrations and people who are like consuming our data and visualizing it in their site alongside their other data sets. When you visit our website and click on visualizations, what you'll find are a couple of interactive reports that we've produced from database queries using Google's Datastudio product. This is a good way for you all, it looks like on this call, to get started. They summarize in the United States our data by different geographies. So county is there, zip code, congressional district, as well as the state level. And on the second page of the report, there's a city summary. These are aggregate reports looking at data by week over 2020. There's also one that looks at other world regions, countries. They're a very approachable way to get started. A couple of blog posts on our blog as well. There's a lot of information on various subjects on our blog, and I put this in here so that when you go back to those links, you can get a little bit of a preview. Basically, there are multiple pages, so you can navigate those at the top left. A date range selector. This is actually dated. Now you select the weeks that you'd like to look at. Oops. And then you can download the raw data, or not the raw data, but the CSV of the aggregate data from that table. It's a good way to get started seeing, if you're in a particular area outside Baltimore or want to look at a different state or a different county, you can do that. If you want to compare the counties and zip codes in the US, we're pre-aggregating that data as a part of what we're doing to replace our visualization website that was mentioned a couple of slides back. So now we're at the point where I have a few specific queries as a kind of self-guided tutorial. And since most folks are either beginner or less in their expertise with SQL, I'm not going to touch through and look at these queries yet, but I'm on hand and available to support you if you get into these and want to explore them in more detail later. My main goal here is to, show you what's a little bit of what's possible and introduce some concepts in SQL that, by a succession of features that are usable in BigQuery. So I wanted to do some sample queries specific to Baltimore and that these results could be explored in Datastudio. So just a series of queries. Query 1 is going to look at just individual upload and download tests from Baltimore since July, this month. That just illustrates a sort of like greater than this date type of query. And then the second query just builds on that by looking at, okay, we want to look at a range of dates, and how do we do that? I'm not going to click on that link, even though I really want to. Next, we want to aggregate data. We want to group the results. So we could look and count the number of tests by zip code in Maryland, in Baltimore, and that query does that. But we also are interested in the providers, right? And I'll touch a bit on the providers and how we represent them in our data in a moment. Then, of course, there's some great functions in BigQuery to aggregate and do statistics. So if we wanted to calculate by zip codes or other geographies, what's the minimum speed in, 21224, or what's the average, median, or maximum speeds? We can get those statistics directly in our query, and that helps to do that. It helps to do that because downloading our data, our individual data, is possible, but it also is very large. So I think you're on the order of hundreds of thousands of tests per year. And then the GIS community will be appreciative of this. BigQuery added support last year. I've been really loving it for geographic information systems support for different functions and fields. So if you are a GIS person or have someone on your team that works on GIS, you can do joins, point and polygon joins. You can use I've used these with Google's public datasets program. Contains some geographic tables, though not all. And the note there about pinning is really about how to add that to your, once you query a Google public datasets table, it pins it in your screen. But we did this with Priya and with the Binya folks. So Binya maintains the shape files, GIS files for the Baltimore neighborhood statistical areas. And so I've loaded that into a table and that's listed in this last bullet. This is now available, and other geographic data sets are available in our provided data. And we do this for geographies that aren't supported or aren't there in the public datasets program. They typically are pretty US focused, not comprehensive. So if I want to look at counties, there may be a table in public datasets. But if I want to look at something very specific to Baltimore, I need to either do that in a GIS program separately from BigQuery, or I need to load it into a table to use BigQuery's GIS functions. And this is the end of the tutorial slides. The last query actually uses that table that I created to join download tests, individual tests, and get for this time range and this and these neighborhoods, these download tests were assigned in these neighborhoods. Now, you can also use other tools, as I mentioned, and this is primarily a resources slide for those of you who may use these tools to get started linking and using BigQuery from within them. So I'm going to just gloss right past that. How do we support community-based research? Now, one of the reasons why community research and collecting new data might be needed has to do with the way that we geolocate the test. How do we know when you run a test where that is coming from? And I mentioned our default data, which is the IP address geolocation, but there are other ways to gather new data with more specificity. And so this section of the talk is going to just touch on 3 tools that can be used to do that, to gather new data. And after I talk through these 3 tools briefly, I will show an example of why these need to be considered when looking at very specific geographies. Piecewise. So Piecewise is just a branded name that we came up with for a website portal. It's software that runs a website, essentially, has a database, and provides a survey builder. So you can, if you launch this code, you can set up a survey, ask some questions. At the end of the survey, the person consents to, well, actually, that's not the right flow, sorry. But part of it is a survey and our speed test, and that uses our platform. And then those data together are saved in your private database. But part of the thing that happens is we use the web geolocation technologies to ask the person who's visiting the page, will they consent to share their location? And when they do consent to share their location, the person running that site gets a more accurate location than what would be in our public data. The other part of the product is a basic map that looks at tests collected by this website over the top of our general default data mapped on top of a Google map. We also have a Chrome browser extension. A Chrome browser extension is called MLab Measure, and it, like other extensions, just gets added to your Chrome web browser, but you can run tests from it. You can schedule tests that happen at specific times over the day. You can annotate the results by saying, okay, this is this location or that provider, or this provider in this tier of service. You can select an MLab server if you want to, a specific one. We recommend not doing that, but the other advantage is this Chrome browser allows you to, it saves every result in a SQLite database within the browser, and then that person can export that data as a comma-separated value file. So it's a lightweight way to gather new data from known locations and could be used in a campaign to kind of gather new data. It also supports localization of different languages. So I think there's like half a dozen languages that's translated into for international users. And we currently have a partnership with UNICEF's Giga Project to upgrade this extension to add the ability to configure an installation of it to push its results to a common database. So UNICEF plans to use this in schools that they support the connectivity for in order to monitor and measure regularly the connectivity that they're receiving. And then finally, Murakami, another branded name come up with from our team. This is a containered service that runs on automatic and recurring measurements. It has been running, and we've been developing this through a partnership with Simmons University through a research grant supported by the Institute for Museum and Library Services. That ended at the end of May, but we have been able to develop this from a prototype to a usable service, a usable code base to install on an on-premise device that plugs into your router and runs tests for you. The data can be shipped off to a common location. So we've been managing those as a fleet in a service called Balena Cloud. So I'm happy to talk more about that as well. But these are 3 ways that new data can be collected now with more geographic specificity. So let's touch on the whys now. Looking at time, just checking, we got 20 minutes left in total, so I'm going to wrap things up soon. And we'll start talking about some questions. how can our data inform your digital inclusion initiatives here at Baltimore? So you're probably thinking of some questions when you came to this talk, and you may have thought of some already since I've been droning on. But some just basic questions. What are the measurements by provider in which parts of the city, and how has this changed over time? What are the differences across Baltimore's neighborhoods and communities, and can that be correlated with other data sets to understand the nuances of service quality across other data set factors? And how can we measure the specific impact of specific digital inclusion initiatives? There's a lot of different ways we might approach that, these questions. I think it's important to start with questions that you want to try to answer, particularly as our data is quite large. We'll either find that we can answer it, the question, or we'll uncover new questions to ask, or we'll find that's what usually happens. And then we may answer some questions too. We'll see. So let's just look at unpacking some of this. What can we do with MLab data? Well, we can aggregate it by geography. As I said, we can correlate it with other data sets. We can build aggregate data in applications or provide other means of contextualizing internet performance, specific locations over specific times. But what does that look like? What does our default geographic specificity look like in our data? So I generally tell folks that our default data is really useful for looking at citywide trends or countywide trends. And then if we want to get into more granularity, like the neighborhoods or community areas, then we need to consider and consider, the specificity here, and we may need to collect new data. And we may be able to use the existing data, but we want to be careful about the things that we say about it and assume about it, and not overstate exactly what it is. So as I mentioned, we collect your IP address, and as opposed to more accurate methods described by, let's say, Piecewise or some of those other tools. But we sacrifice some geographic specificity in exchange for more user privacy. So in the image here, what we see is this is from a Datastudio dashboard that I pulled together just to see what our data looks like for Baltimore. It's community areas. This is a join of the community areas shapefiles, and it places a dot at the center of each community, and in the pop-up you'll see we have the community name, the average download speed and upload speed, as seen in just a general point and polygon. Where was this test? Which area was it in? And if you were to look at those, this looks great, right? But if we were to click on some of these others, we might see that they're very similar across all of these, which might be surprising. And to illustrate, the geographic specificity in a little bit more nuance, I wanted to show this report that was produced it's 2 years ago at this point. But it was called the United States of Broadband, and it's through the Open Technology Institute at New America. So I can drop a link to that in the chat once we get into the Q&A. But I wanted to show the zoom in here. When we look at small geographies like census tracts, you can see we have aggregate data in some areas, but not in others. And so these gray areas, if we were to click on the interactive map, would show us that there's no data for this region. Well, why is that? People must be running tests from Belleville, right, or Arnold, or in the middle of St. Louis. And I chose this region because this is more closer to where I'm from originally, just side note. But let's look at this from Baltimore's perspective. So I produced this visual with QGIS, which is a GIS desktop program like ArcGIS. You can do these types of things sometimes within Google Data Studio, but I find that sometimes it's the tool, you got to just approach the tool for the problem you need. So what we're looking at here are three things. Obviously, the geographies of the communities of Baltimore. And the green dots, what are the green dots? So the green dots, what I did was I looked at, Ruth wanted to look at 2018. And excuse me, Ruth, for conflating you with tree a little while back. I mean, apologize for that. Sorry. All right. So Ruth wanted to look at the neighborhoods and community areas of what are the aggregate speeds across these areas. So in 2018, I grabbed all of our data, basically all of the latitude, longitude pairs for every test in 2018. And you might expect for that much data, hundreds of thousands of tests, to be spread out all over. But actually these 50 green locations are the common locations where every IP address in 2018 was geolocated. So you can now see the issue we run into. What we're geolocating is the infrastructure of ISPs that hands out the IP address. And so those green dots are not in every neighborhood. And even if there was one in every neighborhood, that would not guarantee that that's where you were located, geolocated, if we ran our default test. And just to give it a little bit more illustration, there's 3 blue dots on that map as well. And I live in Highlandtown. So it's likely that the dot over on the farther right is closer to where I'm actually, but what I did was I took the IP addresses that I logged that I had on my home connection over the last few months, just randomly this is some of the things that people like me do. It's like, what was my IP address? I'm going to track that. So, but over time this year, I've been geolocated in those 3 locations, which is problematic if I want to aggregate by community. So how do we deal with this? Well, we have to gather new data. And the tools that we talked about earlier are ways that we do that. So if we know the known locations, we can just compile those and log them. And then we know where those tests are coming from, perhaps from a premise device, or perhaps by asking the person visiting a website to say, yes, I want to share my location. But you can also develop your own tools. You can use our code to do this. You could put up a public engagement portal and a survey. You could use the Chrome extension, the Chrome app, in various locations with known contributors in a network of organizations. That might work well in Baltimore. We can also decide to make a longer term investment to place specific Murakami devices in known locations to gather data over time. And when you do that, you get a much more accurate picture, but with less volume of data, of course. And then lastly, I just wanted to share that, we upgraded our platform last year, and we're now really well poised to take on new open source measurement services. We are prioritizing a global engagement on that, but also in the US, our focus is specifically and intentionally on this the digital inclusion and digital equity communities initiatives in the US. This is really a big part of what drives us as a team. And as we work toward doing that, one of the things we do are community calls. We've started doing them this year, and so far we've done we're trying to get to a sort of 2-month workflow on those. But if you'd like to be involved and follow up on a call, we'd love to have folks in this community join us for that. So just email us at support@measurementlab.net. We'll add you to the lists and announcements. And the reason for I wanted to pitch that is that digital inclusion advocates just give us an informed perspective on what is the healthy internet. And it's not just for folks who can afford fast connections, or really, everyone needs to have access, and this pandemic has really emphasized that. And so engage with us, let us know, help shape our future. That's the end of my slides. I'll just stop. We got 10 minutes left for questions, dialogue. Happy to jump in. I haven't seen too many there in the chat, but I am happy to take questions and just talk about anything you'd like. Thank you so much. Oh, and also, it's really just nice to be in a room with folks who are working on public problems. I am assuming it's just nice to be involved in this community. So thank you again to Binya for the invitation.
Thanks so much, Chris. It's a pretty small group, so folks should definitely feel free to turn on their camera and mic and chat away. We've got a little bit of time left.
And you have access to these slides, so I'll just stop sharing for now, and that way, if you need to view something again, we can load it back up.
So really, obviously, interesting point for us to try and get data at the neighborhood level, and thinking about how to crowdsource that to try and make sure that we have representation across all neighborhoods. That's a good point. And the question is, I guess Ruth would probably have this question if she hasn't asked you already. Can we aggregate to the neighborhood right now, or is that actually not legitimate?
So I think that it is not definitive, I would say. It would be informative. But to really understand whether, Upton is doing better than, another neighborhood, for example, we would need to collect some new data and really get a more granular picture.
Right.
So I think looking at the neighborhood level now can give us a sense of general trends, and I'm continuing to explore that as well. For example, it would be interesting to know that we could, instead of thinking about just the speeds aggregate, we could be thinking about other type of metadata, for example. I didn't touch on this. I guess I touched it, but I didn't go into complete detail. But how do we identify provider in our data is a question I should have touched on. We look up that IP address, and those are registered to systems, like network operators. Essentially, they register what's called an autonomous system. They maintain their system. They get a number assigned to them, and then they publicly have to say, these are the IP addresses we use. So we look up that provider name, right? And sometimes that, in most cases, for the large providers like we have here in the city, those names are the equivalent for to the providers we know from our internet bill, right? In some cases, they're not, and that happens more often in other locations. But they also include things like the universities who run a network, right? So you'll see University of Maryland in there. You'll see. So it would be interesting, for example, with that question, Zima, to say, what are the providers and what can we know about them? I was looking at those 50 points, and I would like to, for example, one of my next questions for myself is, which providers in aggregate are coming into which locations, and where are those locations? What's some other community data about them? Just to try to explore the geography of the infrastructure. Because we know that, even though Comcast provides service throughout the city, supposedly, they're not everywhere. And some businesses have been asked to kick in, large amounts of money to get, a better connection, to build out a link between where they are now and where they need to be at that location. They pay lots of money. But that's not really right. Especially when you have a franchise agreement with a city to provide, whatever. I haven't read the franchise agreement, but I'll stop rambling. New data is needed, but I think general trends would be viewable and help us to think about what's missing.
And to really think about if that's different in Baltimore. I know we complain a lot about the fact that Comcast is our basically monopoly, but I don't know if that's true. So I know, not to call out Jeff, but it's a small group, so I'm going to call out Jeff, but he may be our only non-Baltimore partner. Okay. He's from Chicago. But thanks for joining us, Jeff. He's our partner out in Chicago. But the fact that we have such expensive internet is part of our problem. Why is that true? And can we look at, by IP service, can we look at both speed and also, looking at why do we pay so much for it?
This is a really real problem. I want to let Jeff respond. But have thoughts?
Yeah, I don't have a good answer to that question. I just was interested really in the data source because we've had some interest from folks trying to build data centers in, quote unquote underserved communities, and trying to make the case for how, why there's a need in those communities. And we have poked around trying to understand more about available data beyond just the census essentially. And didn't find anything particularly granular or useful. And this seemed really interesting. So kind of thanks for the overview. I'm looking forward to kind of poking around in your data.
Sure. Feel free to reach out, Jeff, or anyone on the call, or anyone that you share this presentation with.
Sure.
It will get back to us and we will help. We were started within a think tank in DC, prior to coming to Code for Science. And so the intersection of policy is important here, but it's not our primary thing anymore. And I only mention that to say that, there are official sources of data, as many of you may know, for broadband speeds in communities across the country. And the FCC is working on making that data better. We're not here to say that our data is that different data that will replace that. It is not. It is a complement. And so, it's important to make sure that we're just sort of reading these for comparison purposes. Really, the push should be for better transparency and more accuracy in the public data that's provided by the government. And I know they're working on it, so I don't want to badmouth them. But so for our data set, though, it is a useful tool to look at the broader geographical trends, and to split those by provider in many cases is useful. There's a large amount of data that's more interesting, though, when you try to get and collect at a local level. Cost, for example, is something that is highly guarded across the ISP community. They don't, want to share that information, that the cost for this service plan here is, this amount, and over here it's this amount, right? And they're running a business, it's a hard business to be in too, I think. I've never been in it, but it seems difficult. So really is about openness, accountability, transparency, because so internet service is such a thing we all depend on these days. So it's going to become more and more important. So collecting data at the local level, price is a thing, service plans. One of the things you should know, we don't ask the user by default, what's your service plan? How much do you pay for? Are you on the gigabit service or the slower service, or are you on Internet Essentials? That's metadata that we don't capture. It's knowable in a certain way by looking at and aggregating by speed tiers, right? So we can see this is something that we're starting to move toward in representing our data. Talking not just about the median or average or whatever speeds per location, but framing what our data say about what people can actually use the internet for. So if we know that we've got to be able to support a Zoom call, and the kids' online learning, and your partner's work from home use, these things add up and they're knowable speed needs, right? So what we're doing is gathering information about what those applications need, and then we're going to start representing our data by saying that, in this time frame, in this location, X percentage of users could do a Zoom call, could stream video at 4K, whatever it is, because it's much more contextual and makes a lot more sense to what people actually need to know. So gathering new data, pricing data would be amazing. Yeah, and I know that there are other providers in Baltimore. I know AT&T is one, I think, maybe Verizon, but we should look at it. We should just examine it. There's been some other questions in the chat.
John had a question about the list of green dots.
The list of green dots. I don't have their names yet, just the points on the map. Hopefully soon. I think I need more metadata about them. I might need to go drive around and look at them, physically.
That could be a side project.
It could be a side project. I mean, going back to war driving days or something. I know we're at time, so I'll pause there. I don't know if we have to stop right at the hour.
Thanks so much to everybody for joining us. There is a quick evaluation in the chat for you to help us, plan for future events. And our next session starts at 5 o'clock. This was session number 14. Today we're going to get to 15. We're actually going to get to 16 today. That's right. We have another one at 7 after that.
Wow.
But
You all have been busy.
thanks to everybody. I think we can stop recording, and if you have any other thoughts before we close.